Okay, so for today, my job is to help you get a little bit better at these really hard word problems. And the really hard word problem test is on Friday. Okay? You just got to get a little bit better today. So here's the stuff I want to make sure you get. The variables, the constraints, and the optimization equation. Okay? And I want to make sure you at least know what they mean. So if you're going to find the variables, well, there's only two variables, x and y. Look at this chart and talk to the kid next to you about, just from looking at the graph, you should know what x and y are. Talk to the kid next to you. Yeah, do you see down here it says x is cars? And it says up there that y is buses? You with me so far? All right, so that's the variables part. You just got to tell what x and y are. Not incredibly hard. The next part is constraint equations. This is an example. This is not actually the correct answer. Please stop talking. This is not the correct answer for this problem, but that is an example of a constraint. It's an equation. All right? There's an equation like this for this problem. Now I want you to take a minute. It's not 2x plus 3y equals 12. And here's the important thing I want you to rule out. Cross off this for now. Cross off that. Pull up the worksheet. It looks like this. We're going to just start this worksheet together now. This is today's homework. You're crossing off that little middle of the problem because that's the optimization equation. That comes later. You're trying to write me an equation that has something with the x's plus something with the y's, and it equals some number. And x is the cars. Y is the buses. All right, see most of you are on the right spot, which is good. So, what is that first equation? If we cross off this part about the 250 and the 750, because see, that's the part you're trying to optimize. You'll get used to this. There's one equation that's about optimizing. See this? That's going to be the optimizing equation. We'll do that later. Have you crossed off that part yet? Good, cross it off. All right, so then what's left, you should be able to write two equations. Look, they've graphed them. Here's one I'm making blue. And then there's this one I'm making red. There's two equations in there. Take a second. Try to figure out what one of the equations is. Has to do with x's and y's and equaling a number. And then there's another equation that has to do with the 60. All right, take a second. Talk to the kid next to you about what these two equations should be. I'm going to pause while you work on that. Okay. So first you got to ask yourself this as you're making these. It says a car requires 6. Obviously, x goes with 6 somehow. It says cars, 6. Not too hard to figure out that x goes with 6. So what if I said 6x? Plus, and then obviously the bus goes with the 30, so maybe that's 30y. And if it's in the context of this whole parking lot thing, that might add up to a big parking lot of 600. And this would be close, but it's off a little bit. 6x plus 3y equals 600 isn't exactly right. It's really close. Who knows what should change just a little bit to get the equation? Yes?
You gotta rearrange for y.
No, you don't have to solve for y. You aren't wrong that solving for y would be smart, but you don't have to. You can have 6x plus 30y. That's okay. There it is. Less than or equal to. Does the number of the space of the cars and the buses have to be as big as the parking lot? No, the parking lot could be bigger. Right? All right. So less than or equal to 600. I get how you probably would have forgot the less than or equal to. But then how would you have shaded? If it doesn't have a less than, it wouldn't have shaded. And the graph is shaded. Okay. Then there's a much simpler one involving the 60. Somebody, please volunteer. Yes?
X plus 1
Is less than or equal to 60. Perfect. Nice job. That's just the cars plus the buses have to be less than 60. Or could be 60. Nice. All right, those are our constraint equations. Now they've already graphed them. Now it's time to do the optimization part. Pay attention. I'm going to highlight the optimization equation. I think you should too. Now, can you write the optimization equation for that? Now, what are we optimizing? It says how many of each should be accepted to maximize income. So it's income. So I'm going to choose I. You wouldn't have had to pick I, but I think I is a logical variable for income, isn't it? I is equal to... It shouldn't be too hard from here. Talk to the kid next to you about what you think that the rest of that equation is. 2.5x plus 7.5y. You are correct. Raise your hand if you had that one right. Awesome. Okay. Now, do you remember me telling you that all of the things in the shaded area are feasible, but you're going to pick only the corners. And one of these corners wouldn't make any sense. Ryan, do you remember which corner wasn't going to make any sense? Yeah. Well, bottom left. This one. 0, 0. You wouldn't ever pick, I'm not going to put any cars in the parking lot to maximize income. That doesn't make any sense. You're going to put no cars in there, you're not going to get any income. Okay. So let's go to this one. That's one of the options. This is option number 2, and this is option number 3. It's one of those 3. So what you have to do on the test is you have to show me those 3 options put into the optimization equation. So let's just do this first one together. 0, 20. I want to know how much that would come out to. Let's talk about real world. That's 0 cars and 20 buses. The question is, how much income would you get if you had 0 cars and 20 buses? 0 of the x's and 20 of the y's. Oh, so it's really 20 times 7.5. Andrew, what is 20 times 7.5? 150 bucks. That's how much you'll make in your parking lot. Can you guys stop? You're really distracting. It's been a whole hour. I need your attention. So I got 0 cars and 20 buses, and that got me some money. I got 150 bucks. Is that the max? Probably not. All right. So let's go to 5,100. Put in 50, 100 into your little equation and tell me how much money you get for that. Take a second. Here's a calculator. Well, it's 50 for the x's, 10 for the y's. I'm hearing a lot of calculators coming out, which makes sense. I actually know somebody who owns a parking lot and has for like 30 years. It's been a great business. One of my friends grew up across the street from him, and he bought a parking lot when he was fairly young, and then people send him checks. That's as simple as that. They own a certain parking spot. The only thing he has to do is have a tow truck come through every now and then, because somebody will park there when they don't really own the spot, and then those people get towed, and they have to pay for it with the tow truck. That's how the tow truck makes the money. The tow truck gets the money. So the tow truck will police it for them. They drive through there hoping to find somebody who's parked illegally. And grabs them, tows them. They have to pay him like $400 for having his car towed. So anyway, he gets to just collect money. Well, it's kind of like this parking lot problem, except he doesn't charge different things for buses and cars because he only allows cars. Because think about how much room a bus would take up. All right, so how much was that one, Drew?
Well, the 2.5 times 50.
And the 10 times 7.5. Did you do that part
Add
yet?
them together.
Yes.
875.
Thank you. Anybody verify that number? Also got 875? Uh-oh, nobody else is getting that. I'm gonna double check you.
Uh-oh.
What is 50 times 2.5 plus 10 times 7.5?
10, I thought it was 100.
50 times
200.
2.5 plus 10 times 7.5.
Anybody else get
is 200.
200? All right, good. That's all right.
That's 100.
200 for that. All right. And then, Ryan Knorr, did you figure out the third point, 60 comma 0?
It's 150.
Because 60 times 2.5 is 150, is that right? People are verifying 150, is that right? Okay, good. All right, now I see those three, and all that really matters is that the maximum income is the 50 and 10. That gets you $200. That'll get you the most money. So, it's kind of counterintuitive. You might think, I should just put all cars in there. No, actually, ideally, you'd get some buses and some cars. Put it all together, you make the most money. All right. So, we pretty much did that whole problem. Yay. Now remember that problems 2 and 3 are skips. They confuse even me. So then you go to problem 4. Now this is important. I wish they hadn't even said this. You do not need to find the optimized value for the problem, but you do need the optimization equation. What they're saying is you don't need to stick the corners, the vertices, into the equation. Just get the equation. All right, so let's try to figure out what equation this is about. It's about profit. So put P equals. We're optimizing profit, and we sell belts and wallets. Each belt gets them 18 in profit, and each wallet is 12 in profit. Let's do the profit equation first this time. I just underlined it for you. Each belt nets the company 18 in profit. By the way, this is a little bit of a flaw. It doesn't tell us which one's X and which one's Y. So just because we need to be able to look at the key and make sure ours kind of matches the key, you could actually theoretically do this problem either way. So let's see what the key said. I'm pretty sure the key said that X is belts. Can anybody verify that? Yes. And Y is wallets. Just to clarify, in your own world, you could have switched that around and it would have been fine, but it would have been hard to read the key because it would all be backwards. So best to just choose the same way the key did. So X is belts, Y is wallets. Profit is, did you have 18 for each X plus, all right. And then you're going to basically make these constraints. Hopefully you'll figure out some X plus some Y is equal to something else. And usually there's a number in front of the X and a number in front of the Y. Just kind of give you an idea how they kind of look. And then you actually have to graph these. When you're done, you'll have to graph your two equations that you make. And it'll look kind of like this, and it'll have like a feasible region kind of like that. Okay? So your job now, actually do the real graph, actually make the real equations, and I started the optimization for you because it is confusing. Sometimes you think that you're supposed to graph the optimization equation, but you don't. That's why we started with it this time. So don't graph that optimization equation, but do graph the constraints. All right. So this is not easy stuff. If you try hard, you'll do fine on Friday. If you take this week off and just kind of like listen and then don't actually go work at home on this stuff, you will struggle on Friday because it's like a giant word problem and they're not easy. All right, that's all I got for you for the video for today. Tomorrow we learn how to see where two equations cross, like how to solve a system of equations like that. But I'll show you on a calculator tomorrow how to see where those cross. Yes, question?
On like the answer key, it says like that there's like a y is greater than or equal to 0 and x is greater than or equal to 0. Do we have to add that in there?
Good question. In the real world, this is about belts and wallets, right? Do you get that you can't have a negative number of belts? So that's saying that x, which is belts, has to stay bigger or equal to 0. Yes, those are required equations. Because if you didn't have those, your graph would theoretically go downwards forever, but it has to stay like inside here, which has a wall up at x is greater than or equal to 0, and another one for the wallets at y is greater than or equal to 0. Yes, those are important equations. Those are called the common sense equations, because you can't have negative wallets. So x has to be bigger than 0 and y has to be bigger than 0 because you can't have negative wallets, can't have negative belts. All right. So I think for your class, I'm going to just show you all the solving stuff tomorrow. I tried to show the other classes today, but then the class goes really long and they don't have much time to work. So that's all I got for you for today.